Hey guys, I'm Mr. C and welcome to day 2 of summer math. Today we're going to focus specifically on systems of equations. Your warm-up really was it's all about, kind of a review of yesterday, right? Solving for variables here, asked to solve for y. So basically get y all by itself. You're going to move this x over, right? So I guess what we do is subtract 2x from both sides. We get 6 minus 2x. Of course, then I guess if we're going to get rid of that -1 or that negative sign, we're going to have to divide everything by -1. So this becomes -6. This becomes plus 2x, right? And more often than not, you would see that written as y equals 2x minus 6. Of course, those things are algebraically equivalent, but that tends to be what you see when you solve for y. Y equals mx plus b equation. Here, solve for x, right? So make sure we're solving for the right thing. First thing we're going to do is we are going to subtract that 3y. So you get 12 minus 3y, right? And then, of course, we got to divide. If you're dividing this by -6 to get x by itself, you got to divide everything by -6. So x becomes, it looks like 12 divided by -6 is -2, right? And then 3, 6, I guess that ends up being plus. Reduce that to 1/2 y. Okay, so there we are, solving for y, solving for x. I think you guys are going to find out when we're solving systems equations, very often it's helpful to isolate a variable, specifically using the substitution method. And here, solve for y when x equals 3. So basically what they're asking us to do here is just plug in a 3 for x and figure out what y is going to be. And there's a couple ways to do that. One is to get y all by itself, which we could definitely do. We could do that. We could do that just as we have done before. Or we could just plug in for 3 and then just figure out what we get for y. So solving the equation, much like we did in our lesson yesterday. So what I'll do the second method. I'm just going to plug in where I see an x. I'm just going to plug in a 3. Okay, and that, so obviously 4 times 3 is 12, right? Okay, so now it's just a matter of getting y by itself, solving the equation like we've done every time we solve an equation. I'm going to subtract 12 from both sides. All right, so 16 minus 12, I believe, is 4. Divide by -2, right? And so y will equal -2. Okay, and just to be clear here, what I did, this step was I subtracted 12 from both sides to get 4, and here I divided both sides by -2 to get -2. And then finally, solve for x when y equals 4. Very, very similar, except this time what we're doing is we are making y a number, right? If you remember one of my themes from yesterday, numbers are better than letters, right? When we can solve, plug in a number for a letter, we want to. Less variables are better when solving math problems. In fact, you could say it's impossible to solve when you get more than one variable, unless, of course, it's a system of equations or something like that. So here we got -4x plus 16 equals 32. I'm going to subtract 16 from both sides. -4x equals 16. Divide both sides by -4, and x equals -4. Check my math on that, you guys, but I'm pretty sure I did everything right. I plugged in 4 for y, right? I multiplied. I got undid -16, plus 16 by minusing 16, right? And then undid multiplied by -4 by dividing by -4, and ultimately got that answer of -4. Anyway, that was your warm-up, and now for the lesson itself, solving system equations. Now, you see here a review of everything that you learned in Algebra 1 from solving system equations. 3 primary methods that we've used. Graphing, where you just graph, 2 lines, see where the lines cross, and that is the solution, right? Remembering that there's actually 3 cases. There's 3 things that could possibly happen. One is that you have parallel lines, right? This would be the case, especially if you put in slope y-intercept form, you'll be able to see it very quickly because you'd have the same exact slope. meaning you'd have parallel lines. Right? But you would have different y-intercepts, meaning that they are two different lines that would never cross. They are parallel. There is no solution. Now, the reason I said they would have different y-intercepts, because if they had the same slope and the same y-intercept, well, then they're actually the same line. They are algebraically equivalent lines, like these two that you see here. If you have two algebraically equivalent lines, what that means is the same line, which means there's an infinite amount of solutions. So one line is literally the same or right on top of the other line. Solving by the substitution method. And I know this is a review for you guys, but what you would do here, if we said, okay, here's our system. We've got equation 1 right here, right? And we've got equation 2 right here. Arbitrary that I called 1, 1 and 1, 2. But then what you're saying, well, hey, if y equals this, right, and y equals this, well, what that means is another name for y would be 2x minus 3, meaning you could just substitute it in for y, right? So you have the 2x minus 3 equals x minus 6, which is better, right? Because less variables is better. If you have one variable, you can solve the equation. If you have two variables, you can't come up with a solution. So anyway, remembering always when you solve a system of equations, right, once you get x all by itself, then, well, or y all by itself, once you get a solution, right, you have to plug it into one of the original equations to see what y is. Or I guess if you solve for y, you'd have to plug into the original equation to see what x is. Okay, so anyway, that is a review of substitution, and this is your solution. Okay, so anyway, let's look at this next one. Elimination. Okay, so the elimination methods means you add the two equations together and one of the variables just disappears, right? Though when you know you're set up to do that is if you have like a plus y minus y or a plus 5x minus 5x, something like that, you can just add the equation together. One of the variables will just disappear. You have one variable, one equation. It's exactly where you want to be, right? Like in this case, all we have now are x's. We can solve for x. X equals 9. Right? And remember, you're not done when you're doing a system of equations until you have both an x and a y, or whatever your two variables are. So anyway, notice what we did is we plugged into the original equation, one of the original equations, specifically the equation up top, right? And we plug in 9 for x, which is the solution we got, and then y equals -2. And that is why those are our two solutions, right? If you want to see another example, here's another example. Why do they give us two examples? Because sometimes addition elimination is not that easy, right? Sometimes you have to do something to the equation to make the addition method possible. And that's exactly what we did here. If you notice, what they did is took this entire equation here and multiplied everything in it by 3. Why did we do that? Because we're looking at making these y's cancel out. And I know that if I have a -3y, I can make it cancel out with a +3y. That's exactly what they did, right? And notice we added together, okay, the x's, you get 5x. The y's just disappear because -3y plus 3y, it's 0y. And then, of course, adding your numbers or your constants, you get 10, right? Then x equals 2. Remember, you're not done, though, until you go to the original equation, which is exactly what we did here. It doesn't matter which equation, by the way. It doesn't matter, but you probably want to use the simpler of the two equations. Okay, so the quick notes, we called them quick for a reason. That was a crash course of solving a systems of equations, everything you guys learned from Algebra 1. All right, and now for some real MCAS questions. Now, sometimes they won't even ask you to solve the system, right? This is the case right here. Now I'm going to read it for you. This is a real MCAS question. A student has 2 part-time jobs, babysitting and tutoring. The student earns an hourly wage for each job. On Monday, the student earned a total of $130 for 4 hours of babysitting and 2 hours of tutoring. On Tuesday, the student earned $80 for 3 hours of babysitting and 1 hour of tutoring. Which of the following system equations can be used to find x, the hourly wage for babysitting, and y, the hourly wage for tutoring? Okay, so it's a little tricky because you got to remember, so what do we say? Babysitting is x, tutoring is y, so we don't want to mix up the two. All right, probably what you have here is each sentence actually ends up being an equation, right? So let's see. 4 hours of babysitting, which we recognized was x, right? 2 hours of tutoring, which we recognize hourly wage was Y, right? So let's see. So we're looking for this. If I was going to write this in an equation, I would say 4 times X. So 4 hours times however much he gets or she gets for babysitting, right? Plus 2Y, right? 2 times however much she gets for an hour of tutoring equals 130. So that should be one of our equations. Okay. All right. So we can look and see which one that fits, but let's just do both of them here. Tuesday, $80. So it's all going to equal $80 in the end, right? 3 hours of babysitting, which remember you guys was X, right? 1 hour of tutoring, which remember you guys was Y. And let's see if this system matches any of our stuff here. I think it matches D. And it does. So D is the correct answer. So notice we didn't actually have to do any math there. All we had to do is translate the word problem into the math problem. Seems easy, but it's not so easy. Anyway, that's yeah. Notice they're looking for tricks like they flip-flop these two things, thinking they're going to get you to fall for that. I think they flip-flop the X and Y, right? That's tricky because if you just made X tutoring and Y babysitting, you would have fallen for that one. Don't fall for those traps. Be careful, right? Really, all it is just translating a word problem into a math problem, but they're gonna try to trick you. That's exactly what they did right here. Okay. All right. So IXL preview, right? Your homework, part of your homework for tonight will be IXL, as it always is. All right. And all this is asking you, this first one is just going to ask you, is this a solution? Right? So to be a solution, what that means is it has to satisfy both equations, right? So let's see. If I made X -9, right? So I'm multiplying that, -9, and this is 8. Okay, right? Would that satisfy this equation? Wow, there's a lot of math there. I guess we haven't told you can't use a calculator for this, so so you can. So yeah, let me just see if this would be true. Man, why did I have to pick the toughest, biggest numbers to go over it? Well, I did it so that you guys would be ready for it. So 14 times 9, so that ends up being -126, right? Plus 18 times 8, 18 times 8, right? 144. Does that equal 18? Actually, I think it does. Check my math on that, but I'm pretty sure that does equal positive 18. It checks out on the first equation, but it's got to check out on both equations to make this an honest to goodness solution. So here I'm going to make this -9, right? Y is going to be 8. Let's see if it works, right? So 13 times 9, or excuse me, -13 times 9. So we got 117, or -117, excuse me. All right, and here we've got 14 times 8. Let's see. 112. Okay, does that equal negative? You know what? It does. Wow, who would have thought? It actually is a solution because that coordinate pair fits into both, right? It satisfies both equations. So anyway, that is true. It is a solution. All right, this one is asking us to graph solve by graphing, right? Okay, so graphing, this top one might be a little tricky because you could either get the X and Y intercepts if you want, or you could do what we did in our warm-up and get Y all by itself. I'm going to do that. So I got -3Y, sorry if this is a little hard to read, equals -9 plus X, right? Divide both sides by -3, right? We can divide everything by -3. Y equals 3, I guess, plus -1/3 X. I guess I could have also said -1/3 X. So anyway, I can graph both of these here. My y-intercept is 3. My slope is -1/3. The thing, I guess, when you solve by graphing, which of course you guys are doing this on the computer, so you just click a bunch of things, and it makes sure your graph is nice. But I don't have that luxury because I'm just doing this freehand. I got 1, and I go up 5 over 3. 1, 2, 3, 4, 5. 1, 2, 3. Okay, all right. I think my solution was probably a little sloppy there. I don't know. Yeah, well, hey, you guys are you're gonna have the glory of using your IXL graph that will be very neat, and you'll find your solution. But anyway, where the two graphs crash, that's your solution. Looks like it's probably like 1, 2, or something like that. Okay, solving by substitution. Right now, we don't need to go over this again because I know that you already did. But how would I solve this if I was doing this? Probably what I would do is I would get X or Y all by itself, right? I like the idea of getting Y all by itself because I like multiplying by 10. So what I would do here is I would just subtract that X. I say Y equals 16 minus X, right? And then what I would do is I would stick in that 16 minus X right there, boom, and I would have my new equation, which would be negative 8X plus, well, I guess I'm gonna have to do a little distributing here, right? Anyway, that's a great place to be. I got one variable, one equation. That's all I need, right? Remember to distribute that 10, right? You're going to have to do that. You're going to get X all by itself. I know you guys. I saw you guys in Algebra 1 and geometry. You're very, very good at solving equations when you have one variable and one equation. But just remember, once you get that, right, you're going to have to plug it in to one of the original equations to also solve for Y, right? Addition elimination, right? Just like you guys saw on one of those examples there, right? You are not ready to do additional elimination until you get these set to cancel. Now, what I would probably do is I would probably multiply the bottom by 2. The reason I would do that is because I think the easiest thing to cancel out is the X's here. Of course, you could have multiplied the bottom by 4 and canceled out the Y's. That would have worked too. Remember, if you're multiplying an equation by something, you're going to multiply everything by that, right? And now what happens when you add these equations together? Poof! Those X's disappear. You're left with only Y's, right? And I know you guys, once you guys are in a situation where you only have one variable, you're right where you want to be because you can just use all your solving equation skills that we learned last lesson, right, to solve that equation. So anyway, remember, once you get your Y, plug it in to get your X. And then finally, I believe this is finally, right, solve by using any method, right? I'm looking at these two, the one on the left, I would probably use addition elimination, right? Because I'm looking at that, I could just multiply the top by 2 and I would get rid of my Y's. Here, I would definitely use substitution. This might look a little confusing, but it's actually the easiest problem you could ever have because they're actually telling you what X is, literally, -1. So really, there's no mystery there, you guys, right? Just remember, if you remember from last lesson, numbers are better than letters. If they give you a chance to substitute a number for a letter, you take that chance all day long. And I believe that's it, right? Your homework assignment right here, this is just one example of an MCAS question where you have to solve a system of equations. Yeah, so just do it, your choice, addition, elimination, or substitution, although it looks like it's kind of set up really nice for addition, elimination, not to give it away. But anyway, you guys, I'm Mr. C. I hope you guys enjoyed this lesson, and I'll look forward to seeing you guys tomorrow.